Today, we're going to show you everything you need to know to install professional quality DIY LED strip lights in your kitchen cabinets. This is going to be a very thorough and detailed video covering everything from selecting your components all the way through installation. So if at any point you feel overwhelmed, feel free to jump ahead to the end of this video where we have a 15-second clip of a cat playing piano that you might enjoy. Hey, this is Pete, the DIY smart home guy, making all the mistakes so you don't have to. When we got new kitchen cabinets, my wife somewhat foolishly allowed me to install LED lights as long as there were no visible cords and I don't screw anything up. Now, as much as I hate planning, it is generally a good idea, but especially before you drill holes in your wife's new kitchen cabinets. So here's the plan. We want LED strip lights under each cabinet, above each cabinet, and under the toe kick. We want each level to be able to turn on and off and change colors independently, and we want the LED strip lights to have true whites and excellent colors. The lights will be automated based on time of day and motion, but we also need manual controls on the wall when the automations aren't working the way we want them to. And like I said, this all needs to be done without seeing any wires. With this plan, it quickly became apparent that a plug-and-play solution like Philips Hue or Govee LED strip lights were not ideal, which is kind of a bummer because they are so much easier to install. But those LED strips can only be cut every foot or so, you don't have as many choices for the type of strip you want, and you have to deal with their plugs, so if you really want the precision of a professional install, DIY is the only way to go. Now, unlike those plug-and-play lights that have everything you need in one package, doing this DIY means we need to select the LED lights, controller, and power supply independently, and figure out a way to wire them all up. We'll start by selecting the LED light strips. There are a lot of options, but the most important considerations are type, LED density, and voltage. For kitchen LED lights, the ideal type is an RGB CCT LED strip. These strips essentially include an RGB LED chip for color and two white LED chips that allow you to adjust the white color temperature. These cost more than RGB strips, but RGB strips attempt to create white using a combination of red, green, and blue lights, which is terrible. It makes you look like you just got off the tilt-a-whirl after eating a 2-pound burrito. No bueno. Granted, these RGB CCT strips do not give you the crazy effects that an individually addressable strip will, but again, those strips are an RGB strip, they don't have good white colors, and you know what? I really don't need to be having a disco party in my kitchen every night. The next thing to consider is LED density, or LEDs per meter. A lot of plug-and-play strips have 30 LEDs per meter, which is like a fun-sized Snickers that just leaves you wanting more. If you want even lighting, 60 LEDs per meter with the diffuser is what you should be looking for. Now, there are strips that go up to 90 or 120 LEDs or more, but that adds expense and heat and is really not necessary for under a kitchen cabinet. Your other option is cob lighting, which is a continuous LED strip with no dots. Kind of looks like a neon light. If your LED lights are exposed, cob lighting is definitely the way to go. But for indirect lighting under a cabinet, 60 LEDs per meter are the right choice. Finally, you need to select a voltage. For DIY LED strip lights, your choice is generally between 12 volt and 24 volts. 24 volt strips are good for long runs to avoid power drop, but their cut lines are twice as far apart as 12 volt strips, so they offer less precision and are more expensive. Taking all that into consideration, I went with these RGB CCT LED strips from BTF Lighting. They have 60 LEDs per meter and run on 12 volts. They also have an IP65 silicone waterproof coating, which is not enough to take it in the tub with you, but it will prevent disaster if it gets splashed by water in the kitchen. Next, we need to select a controller that runs on 12 volts and has RGB CCT outputs. If you don't have a home automation hub, you should get a Wi-Fi controller that allows you to control the light strips from a mobile app. I, however, do have a smart home hub, so I am choosing this Zigbee 3.0 controller from Glidopto. It is compatible with the Philips Hue bridge, so I can control them with the Hue app, which I really like. The Hue bridge is also connected to my home automation hub, so I can automate the lights and control them with any other switches connected to my hub. Finally, you need a power supply. Check your light strip for the proper specs. In this case, each controller needs a 12 volt, 10 amp power supply. Before you start installing anything, test your strips, controllers, and power supply to make sure they work. Or don't if you like surprises. Okay, now that we have our supplies, where are we gonna put all this crap? A lot of people choose to use the outlet above their microwave and shove all the controllers and power supplies in the cabinet, but I opted against that for two reasons. First, I'd have to drill a bunch of holes in the brand new cabinets and take up a bunch of space. And second, according to code, the microwave is actually supposed to be on its own dedicated circuit. And morally, I just can't be advising my millions and millions of followers to be breaking important codes now, can I? So after much consideration, we are putting the control center right here, inside the pantry above the door. There's plenty of empty space and nobody's ever going to see it. It's perfect. Except there's no outlets in this closet, so we'll have to add one. We can pull a wire from the switch here and run it up to where we want an outlet up here. If you have never added an outlet, it's not particularly difficult. Maybe I'll have a video showing you how to do it by the time you watch this, but until then, I'd recommend doing some research before just winging it. Now that we know where everything is going, we need to run our wires. Our RGB CCT LED strip requires 6 wires between the controller and the strip, and any gaps between strips. There are dedicated LED ribbon wires for this purpose. However, those are stranded 22 or 24 gauge wires, which are quite small, and the smaller the wire, the more chance of power drop, and if the power drops, your lights will be dimmer on one side of the strip than the other. Because I'm running wire through walls that run up to 20 feet long, I decided solid 18 gauge wire was a better choice. And this thermostat wire, despite being an ugly brown, is perfectly designed for that. Now it turns out choosing solid copper wire is a little more difficult to work with than stranded wire, as you're going to see later, but hey, the LED lights look great from end to end, so I guess it was worth it. To power our LED strip, we have 8 lines coming out of our control panel. Vertical wire runs will be hidden in the wall, and the wire between these 2 cabinets will run down inside the wall, through the inside of the sink cabinet, and back up through the wall. I had to drill some rather sizable holes in the wall to fish these wires. Fortunately, I was able to do this after the cabinets were installed, but before the backsplash was added, so I knew all these big holes were going to get covered up by tile. And the holes I drilled above the cabinets? Well, unless you're 10 feet tall, you can't see them, so who cares, right? But this is where we started running into some troubles. Have you ever pulled wire through an exterior wall with insulation? Yeah, neither had I. It's terrible. Feeding a fish wire between the insulation and the wall, and then finding the other hole without being able to wiggle it back and forth from the bottom, it's nearly impossible. But with a lot of time, effort, and swearing, we were able to get it done. When you pull the wires through the holes, make sure you give yourself plenty of extra just to give you a little cushion to work with in case you screw something up later on. One important note here on wiring, be sure you're labeling your wires as you go. That way you'll know exactly where the wires go later on and you're not gonna have to spend a ton of time figuring that out again, which I know because I didn't do that. With the wires all set, it's time to install the LED strips. For the lights above and below the cabinet, we are gonna put them in Hubitat LED diffuser channels. These channels help deliver a perfectly even light along the entire length of the strip, and it prevents the LED dots from reflecting on the shiny tiles. It also has a nice professional finish for anyone shorter than 4 feet tall that can actually see the bottom of your cabinets. I chose not to use a channel underneath the toe kick, but only because we're redoing the floor soon with a luxury vinyl plank that has non-reflective finish. The metal diffuser channels are easily cut to size. You can use a hacksaw, but it's much easier to use a chop saw or an angle grinder. Pro tip, check that the blade is on tight before using power tools. You can just cut the plastic diffuser with the scissors. As you measure the length of your channel, be sure to leave a little bit of space between the end of the channel and the cabinet frame for the wire and the connectors. I found that the ideal location is to place them about 8 inches from the wall for the best light. If the cabinet frame is in the way of your strip, drill a hole through the frame and run the LED strip through that hole. To install the channels, screw the included brackets to the bottom of the cabinets, then the channel just snaps right in. Now we can finally install the LED strips. Again, measure the length of each strip you want to install and cut the strip on the nearest cut line without going over. Before you install these strips, you'll need to attach some way of connecting the wires. The ends of the LED roll already have wires attached, which is great. But for the places that have been cut, I'm using these solderless connectors. I'm actually going to cut these in half and attach this part to the strip and these wires to the wires that are running through the wall. Because our LED strip has a silicone coating, I need to strip that coating off the end so we can slide the bare strip into the connector. Make sure each metal tab on the connector is touching one and only one copper lead on the strip as you slide it in before you snap it down. After cleaning the surface of the diffuser channel or under cabinet with rubbing alcohol, peel back a portion of the sticker on one side of the LED strip and start to stick it in place. Really press down hard and hold for several seconds to make sure it sticks. Then continue moving down the strip, peeling and sticking as you go. With the LED strip in the channel, you can snap the diffuser piece in place. Then snap the channel into the brackets underneath the cabinets. One strip down, a dozen more to go. And I'll tell you, even though I didn't use diffuser strips under the toe kick, they were still a pain in the butt to install. Literally and figuratively. Now to attach the wires from the LED strips to the power supply wires. My initial plan was to solder them for a nice clean look. I realized immediately that this was one of the dumbest ideas I've ever had. I would still be soldering wires if I stuck to that plan, So next I tried crimp connectors, but those are not designed for solid core wire. So after some research, I landed on these lever wire connectors I found on Amazon. Holy cow, are these things amazing. You just strip the wire to the right length, slide it in the hole, and close the lever. Then just do that 168 times. It's great. You will be so good at stripping wire by the time you're done with this project. You'll find these floating around your house for months. If you have to negotiate a corner like I do under this cabinet, you'll have to cut the LED strip to make the turn. Then you'll use some sort of corner connector to reconnect your strips. But don't use these, they are hot garbage. The solderless connectors I use for all the other connections work much better. As you may have noticed, in some circumstances I am connecting wires of different colors together. This is because the wire colors on the connectors don't match with the colors of the wires running through the wall. Also, the wires from the connectors are not in the same color order as the colors on the LED strips, so be sure you track all of these differences with easy read chicken scratchings like this. Then you'll only have to redo the wiring on a few strips instead of all of them. Alright, we're in the home stretch now. Time to set up our control panel. In order to make mounting the components easier, I cut a board to fit perfectly in the space above the door. Now I can mount the power supplies to the board using this industrial grade two-sided tape. I also secured each power supply with some wire in case the tape doesn't hold forever. The Glidopto LED controllers are secured to the board with Velcro tabs. Now I can take the board to the pantry and screw it in place. Next, we'll prepare a short wire to connect to each output from the controller. Now we need to match up all the wires running from the strips to the corresponding wire from the controller, and then connect them all with something like a twist connector or a wagyu connector. In the end, you'll have kind of a mess of wires that I just kind of tied up and out of the way like this. Again, nobody's looking up here, so it doesn't bother me, but I'm sure you could find a more elegant solution if that's your thing. Now I'll plug the controllers to the power supplies and the power supplies into the beautiful new outlet we added. And now for the moment of truth. Ow. A couple wires are in the wrong controller, but after we take care of those, glorious. We have some finishing touches to address. To tuck our wire connectors out of view, I'm using the same two-sided tape I used in the power supplies. Then I'm attaching the wire to the bottom of the cabinets using a hot glue gun. Be sure to use plenty of glue and a high heat melt for a stronger hold. Oh, and wear gloves, it hurts. In the pantry, I also used a combination of hot glue and staples to run the wires along the door frame to the controller. Zip ties also help a lot with cord management coming into the pantry. So, did I succeed in my goal of hiding all the wires? In my mind, yes. Even though they are exposed under the cabinet, I can't see them when I'm standing or sitting at the table. Out of sight, out of mind. However, my wife is shorter than me, and while she can't see them while she's standing, can while she's sitting at the kitchen table. So is this something I need to address? Should I paint the brown wires white? Should I make her sit in a phone book? Let me know in the comments. And what about the wires on top of the cabinets? Yes, it's a hot mess, but it's a hot mess you can't see without a ladder. So is it really a hot mess at all? My wife and I differ on that. But one thing we both agree on is that the LED strip lights look great. And just like me, you can do it all by yourself. All it takes is several of your precious weekends and this massive pile of tools. But the total cost was under $500 for something that would have cost several $1,000s to have installed professionally. And that is money I can use to go golfing, if I hadn't already promised to redo the kitchen floor. Thanks so much for watching. Check out part 2 to see how we automated these lights. And finally, as promised, here's a video of a cat playing piano. See you next time.